Welcome to 360DigiTMG. Today we are going to understand about BioGPT. Okay, so we understand what is BioGPT. For that, we have the following agenda. So firstly, we'll start with the introduction. So what is a BioGPT? So BioGPT is a domain-specific model which particularly focused on biomedical fields. It uses a transformer architecture, which is a popular AI architecture for understanding the languages. Okay, it follows encoder-decoder mode. Pre-trained, it has been pre-trained on this biomedical field. Okay, where we will get this data? So we will get the data from a massive amount of predefined data sets. Like this model, which is BioGPT, is trained on 15 million PubMed abstracts, allowing it to comprehend and generate text related to medicine, biology, and health sciences. So it has trained on 15 million data set. Okay. So firstly, what can it do? What can it do? What can it this BioGPT can do? So it can answer a biomedical questions. For example, if you are using this model, you can use it for question answering purpose. You can use it for text summarizations. You can use it for text generations. Okay. So there are different applications that we have already understood in the previous lectures. Okay. So this GPT model can be used for answering the biomedical related questions. It accurately responds to complex queries in the medical domains, which can potentially even surpassing the human experts in some cases, like human scientists and other people who are actually from years they are working on that. This model can actually answer that questions which humans can also we can like humans experts can also not answer. Okay, at that particular duration, within that particular duration. Okay, that is important. So it can be useful for text generations. Okay, it can generate various biomedical text formats like research summaries, drug descriptions, or even scientific hypotheses. Okay, so for all these purposes, it can use and it can generate some descriptions, some prescriptions. Likewise, it can do. Then mining biomedical literatures. It can extract insights and identify the patterns from the extensive amounts of scientific publications. Okay, like biomedical publications, which are there. And it can be useful for drug discovery. It assists in identifying the potential drug candidates and predicting their properties. So that what it can do? It can speed up the recovery or speed up the research process. Okay, if the a certain drug is, we found that the certain drug is present inside the certain candidates, we can use it for like, it can predict and so that we can use it for speeding up the recovery of the process. Okay, so all these we can do with the help of BioGPT. Then what is the architecture behind this? So it has a transformer architecture. Okay, so transformer based. As it codes, BioGPT employs the same transformer architecture which is there in the GPT models as we used from OpenAI. Okay, GPT 3.5, GPT 4, as you used in your day-to-day life. This BioGPT also has trained on the same amount of architecture. Okay, so this architecture has proven highly effective in various natural language processing tasks. So what is there inside this architecture? What is that? So it has the encoder-decoder structure within. Okay. So what will encoder do? Encoder will take the inputs. Okay. It will form some context vector. It will form some, it will fetch the most important details from there and it will form one context vector. This context vector is then given to the decoder layer. Decoder layer will generate the output for the given questions or given task with respect to one by one inputs. So in between, in that encoder-decoder structures, we have one layer called as attention mechanism. So this attention mechanism plays a crucial role in focusing on relevant parts and input text. Okay, whatever the input text a user has put. Okay, so it will take that, it will form one memory, it will go to the past, it will form that whether this information is available within our past or not, or if it is new, it will store it in the past also, and then it will generate the output. Okay, so this is how the context vector is formed. Then we have multi-head attentions. Multi-head attention means, for example, we have one input. Okay, we have one input. For one input, we have multiple projections. Projections in the sense, for one perception, we have multiple layers or multiple perceptions for that particular input. Okay, so we will take all the projections, we will take all the perceptions for that particular input, and then that is called as what? And then we will concatenate that, and then all we will use in our model. Okay, so that is what is called as multi-head. Multi-head means we will take multiple projections, multiple inputs. For the one input, we are taking multiple projections. Okay, suppose one incident happened. For that particular incident, we will have multiple projections. So for all the projections we will consider, and then we will feed it into the encoder layers. Okay, then encoder layers will do what? Encoder layer will find out the important scores. Okay, it will find out the important scores. What are the important scores here? Okay, according to the important scores, weights are given. After giving the weights, we will multiply it with the vectors. Okay. After that, we will get one attention score, multi-head attention score, which is in the format. Okay. So for one input, we will go across all these things. Okay. Then the next input will come, the next input will come. So all the layers, one encoder layer will have all one inputs. Okay. The next encoder layer will all have this multi-head attention mechanism. Then third encoder layer, fourth encoder layer, all the encoder layers then merge together and it will be sent to the decoder layer. Okay. So this is how we will form the context vector from the transformer architecture. So here we will understand about encoder-decoder structure. So BioGPT likely uses a stacked encoder-decoder architecture. The encoder processes the inputs. Okay, it will form a context-aware representations. It will form one like a machine encoded format. The input will be always in the textual format, right? So it will form just how we will form the embeddings. That is how we were going to build the context vector or context-aware representations. Then it will be sent to the decoder. Decoder will generate the output according to that of the inputs. Okay, word by word, it will consider the encoded information and the previously generated information which is there within the state. Okay, which is there in within the memory, within the state. Okay, it will take whether the in the past, whether this kind of information we have or not. It will go and fetch the information from the past if it is relevant. Okay, and whatever the current information, that also we will take, and then we will form one output. Okay, so this is what the encoder-decoder structure do. Then what is there in the attention mechanism? So attention mechanism is one layer. Attention mechanism and multi-head attention mechanisms are one layers within the encoder. Okay, there is one encoder for one input. Suppose there is one input coming. One input will go into the encoder state. Okay, within this encoder state, we will have attention mechanism and we will have the multi-head attention mechanisms. Okay, so as I have told you, what is there in the attention mechanism is, it will take both encoders and decoders relays on the attention mechanisms. Okay, so these mechanisms focuses on the relevant part of the inputs or whatever the information which is there in the already generated text, which is a past information. Then it will form one context-aware processing and it will avoid the irrelevant information. Irrelevant information means it will find out the most important words from here. Okay, only the most important words it will take, important words, and then it will form one context vector. Okay, so likewise, we will have multi-head attention mechanisms. In the multi-head attention mechanism, this BioGPT likely uses this multi-head attentions, which will allow them to attend the multiple aspects of this input. For one input, we can have multiple projections. Okay, for example, you know one person, okay, you know your perception about that person, but there are multiple other persons who are also having the perception about this. That may vary. Okay, so we will consider all the perceptions and we will feed it into the encoder layer. Okay, then it will find out the most important features from there by using the alignment scores and other things. And then it will find out the context vector. Okay, so this is a encoder decoder architecture. Within the encoder decoder architecture, we will have the attention mechanisms and multi-head attention mechanisms. Okay, I hope this is clear. So after that, we will have biomedical training data. Okay, so how the data is collected? How was the data? Okay, so it has massive corpus is there. So BioGPT is trained on massive corpus of biomedical text, which includes specific papers, research reports, clinical data, and other relevant sources. Okay, so it ensures it understands the domain-specific terminologies and concepts as well. Okay, it should understand. Means whatever the biological language, for example, for trees and other things, we have from biological language, right? So likewise, we will consider all the things and we will collect that data which is specifically focusing on biomedical text and information related to that. Then we will have a tailored vocabulary, which BioGPT's vocabulary is specially curated to ensure biomedical terms, which will minimize the confusions with general purpose vocabulary, which used in traditional GPT models. Okay, so it ensures accurate processing of specialized language. Okay, whatever the language they are using. Okay, biological language. Okay, so how we are going to fine tune for a specific task? Okay. So for that, we have the adaptability. BioGPT can further be fine-tuned on specific biomedical tasks, such as if someone want to use it for drug discovery analysis, or someone wants to use it for question answering purposes, or for different purposes they can use. So they can fine-tune this pre-trained model and they can use this model for their own purposes. So here we can use it for drug discovery, we can use it for clinical trial analysis or protein interaction predictions. Okay, this enhances its performance and makes it even more valuable for various research and application areas. Okay, so what are the different key aspects, key components which are there? Okay, so first we have an embedding layers. Okay, so embedding layer is nothing but this layer will convert the words or a subwords into the numerical representation format. Okay, this is how we are going to find out the context vector, which will allow the model to process them and understand them. Okay, then we'll have loss function. This function will guide the model's learning by processing the feedback on how well its prediction matches with the desired output. Okay, prediction minus desired output will give us the loss function. Now, after that, we will need to minimize the loss functions. For that, we will have different approaches. Okay, we can apply different approaches. Then we'll have optimization algorithm. This algorithm will adjust the model's parameter, which will be based on the loss function, which will help it learn from the training data and improve its performance. Okay. Then there are these key components will combine to create a powerful language model, specially designed for intricate worlds of biomedical text. Then what is a workflow? So workflow is like this. We first have the inputs. Biomedical text is feed into the models as a sequence of tokens or words or subwords likewise. Okay, so whenever the new user will use this, okay, they will use one textual format, right? The textual format is then feed into the system. The textual format will be converted into one words, subwords, or what we can say. We can use the embeddings. The next step will be embeddings. Okay, embeddings. Here in the inputs, we can use it as a token embedding. We can use it for different embeddings are there, position embeddings. Okay, so after that, after getting the embeddings, what we are going to do, each token is converted into the numerical representations into the embedding layers. After that, it will go enter into the encoder states. The encoder processes the input sequence and then it will incorporate the conceptual information through the attention mechanisms. Now, what is there in the attention mechanism? In the attention mechanism, we will have the importance scores. Okay, we will give the importance scores according to the what we can say, the whatever the tokens or whatever the inputs embeddings we have. Okay, according to that, we will give the importance scores. Okay, the most important scores which are there, we will take that and we will skip the rest. Okay, so this is how we are going to do. Then there is decoder. Then we will form one context vector and then the context vector is sent to the decoder states. This decoder will generate the output text. Word by word it will do. Okay, just how word by word, one input, second input words we have taken. This is how it will generate word by word. Okay, and it will take into account the attention mechanism as well as the previously generated words for us. Okay, then the last layer is an output. The final output is a sequence of generated tokens, forming the coherent biomedical text. This will be the last thing. And then it will be generated to the output links. Okay. So this is the total workflow, how this BioGPT will work. Now, what is the key differences from the general purpose GPT to that of BioGPT? So, the key difference from the general purpose GPT models are the training data. Now, the GPT model has trained on all over the areas. Okay, it has trained on massive amounts of others also data set, not only the biomedicals. So this here in the BioGPT data set, the training data is massively trained on biomedical text. Okay, which will ensure that it will understand the domain-specific language and concepts. Okay. Then the vocabulary. Its vocabulary is tailored to biomedical terminologies, which will enable the accurate processing of specialized terms. Okay. Then we'll have the fine-tuning. It can be further fine-tuned on specific biomedical tasks to enhance its performance in those areas, whatever the areas might be. Okay. Then what are the different benefits of using this? So, we have an improved performance of biomedical task or biomedical text processing task. Okay, if we are using this model, we can use it more accurately, more importance we can give to, it is specially designed for biomedical terms. Okay, so for that people, they can use it and easily access and easily they can get the answer, whatever the query they have. Then we'll have better understanding of biomedical language and concepts. Okay. Then there is ability to generate the realistic and informative biomedical text also. Okay. After that, we'll have potential to assist in various biomedical research and applications we can use and we can publish that. Okay. So these are the things. These are all the applications related to BioGPT. Okay. So what are the key takeaways from here? So we understood about human level performance. Sometimes this BioGPT has achieved human parity in certain tasks, meaning its performance rivals that of the expert scientist in specific areas. Okay. So it can give you a quick answer. And as we know, time is important. So it can give you a quick result. As you are just asking the question, you will get the answer like this. Okay. So boosting research. It can accelerate the drug discovery, analyze the vast data sets, and guide the researchers towards the promising avenues also. Okay. Then improving the healthcare sector. It can help the doctor assist, or it can help the doctor understand the complex conditions. It can personalize treatment plans you can give for particular person. What is the issue? According to that, we can give the personalized treatment plan according to this model. Okay. It can facilitate the better communications with patients also. Okay. So these are all the takeaways from this. Okay. So let's have one quick recap of what we have understood up till now. So we have understood that this is a BioGPT. Okay. What is BioGPT? BioGPT is nothing but a model which is trained on massive amount of biological data set, medical sciences, and healthcare. Okay. So these are all the data set. It can be useful for what purposes it can be used. It can be used for question answering. It can be useful for text generations, mining biomedical literature, drug discovery, so on and so forth. Okay. Then we have understood this architecture is also based, this architecture will also follows the original architecture, which is GPT models from the OpenAI. Okay, so we have understood about what are the architecture it follows, what are the different layers, what are encoder decoder structures, what is attention mechanism, what is multi-head attention mechanism. Okay, then the training data set. Okay, so yes, we can do the fine tuning for the specific task. We can do it like if someone wants a different business problem, which is related to biomedical terms, they can use this and they can fine tune this model according to the requirement, and they can solve their business problem. They can save their time also by building new model and other things. Okay, so this can help in transfer learning. Okay. So other key components like there are embedding layer, loss functions, optimization algorithms. Likewise, we have in this architecture model. Okay. So this is how the workflow is: import embeddings, encoder layers, decoder layers, and then we'll have the output layers. So this is a general difference between what is BioGPT versus the original GPT model, general purpose GPT models. So it is domain specific, what we can say. It is domain specific. It is generally used for biomedical people. Okay. That is how we can see. And this is the benefits we can take from this model. And these are all the key takeaways. So this is it for today, guys. Thank you for joining. We'll meet you next Saturday with